Mastering conditional logic means our robot now has a brain. On top of that, we also need to equip it with the ability to tackle tons of repetitive work. Loops. Everyone knows, every time the subway pulls into a station, it announces the arrival info. In this process, the specific station being announced changes each time, but the action of playing the arrival announcement stays the same. A process like repeating the same thing for a set of similar items is called a loop. Here, the similar items can be a numeric range, a list, or a set of elements. In Automa, all loop-related commands are in the loops set. So what does a loop consist of? Drag in a loop. This command can run a specified number of times. For example, if I want to loop 5 times, I just need to set start from to 1, end at to 5, and increment by to 1. The number generated in each iteration will be saved to loop index. Add a print between loop and loop ends, and set the content to print as this is the loop index iteration. Run it. The print action repeats 5 times, and loop index increments accordingly. Up to this point, you might still be fuzzy on how this loop works. So let's break it down step by step. In the first iteration, the starting number is 1, loop underscore index gets assigned 1, and it prints this is the first iteration. Moving into the second iteration, since the increment is set to 1, loop index needs to go up by 1 from its last value. So it gets assigned 2, and it prints this is the second iteration. Moving into the third iteration, loop index goes up by 1 again from its last value, so it gets assigned 3, and it prints this is the third iteration. Moving into the fourth iteration, loop index goes up by 1, so it gets assigned 4, and it prints this is the fourth iteration. Moving into the fifth iteration, loop index goes up by 1 again, so it gets assigned 5, and it prints this is the fifth iteration. Since we set the end value to 5, adding 1 to loop underscore index at this point would go beyond the range, so the program stops here. In this process, the loop index that keeps changing as the loop runs is called the loop item, and the print that stays unchanged is called the loop body. A loop is made up of these two parts. The loop item is the data or element being processed in the current iteration. The loop body is all the commands that need to be run repeatedly, meaning everything that has to be done over and over, placed between the start and end of the loop. We'll use loop to walk through a real case. After pulling up the store's order page, the page numbers at the bottom show there are 5 pages total. Next, we want to set up automatic page turning for this page, which basically means looping the click the next page button action 5 times. First, grab the current page, pick Google as the browser, and name it Playground Web Page. We can just reuse the loop structure we built earlier. This time, the loop body isn't print anymore. It's clicking the next page button. Capture this page turn button and name it Playground Order Next Page. At this point, click Run, and you'll see the program perform the page turn action. However, the current loop count is preset to 5 times. Can the program automatically grab the total number of pages for smarter loop control? After checking out the page's layout, we notice the text on the left shows the total page info. So as long as we pull the element's text content, we can get the total page count. After capturing the element, name it Playground Order PageNum. To get the element's text content, use getElementDetails. Pick the specified element and name the retrieved text PageNum text. Add print to output this variable. Disable the following commands and hit Run. The text prints successfully, but our target is the number 5, so we still need to figure out how to pull the number from this text. When we covered strings, we mentioned that text has a bunch of operation commands. In data processing, find the text set. Based on the command name, you can tell extract from text is the one we need. Drag it over, Pick page num text as the text to process. We need to extract the number in the text, so leave the extract mode as number, name the extracted number page num, and click Done. Swap out the variable in print with the extracted page num. After running, it successfully outputs the number 5. Now we can set the end value in loop to page num and turn it back on. Reset the page state and hit run again. You'll see even though the final result is the same as before, this time the flow is way more flexible and stable. That's because we changed the loop's end condition from a fixed number to a variable calculated dynamically based on the web page's actual info. So whether the order list has 5 pages or 50, this automated flow can adapt, grab data from all pages accurately, and you won't have to tweak any code manually. However, the current flow still has a small flaw. Even though the total number of pages is 5, in practice you only need to click the Next Page button 4 times. Because page 5 is already the last page, there's no need to click to turn the page again. In other words, we only need to run the click action when loop index is less than the total page count page num. We can add an if before clicking. The condition is loop index less than page num, and then drag click element into the if block. Reset the page state and rerun it. And the flow will be pretty much perfect. Besides looping through numeric ranges, we can also iterate over a set of data, namely a list. Last lesson we learned, every item in a list has a clear positional relationship. Iterating over a list basically means pulling this set of data out in order based on their positions and processing them one by one. So how exactly do we do this? For list iteration, Automa has a corresponding command for each item in list. Next, we'll put together a quick example using this command. The requirement is, in this search box, search for t-shirt, dress, and hat in sequence. Since we need to loop through a list, first we have to create a list to store these 3 items. In Canvas, add set variable, pick list, set the assigned value to t-shirt, dress, hat, and name it item list. Pull items out of the list one by one using for each item in list. Select item list and name each extracted item current item. The loop action is to fill the iterated items into the web page's search box, then click the search button. Still use get specified web page to grab the current page, pick Google as the browser, name it Playground Web Page, and drag it to the top of the flow. Next, head to the page to capture elements. Name the input box Playground Order Search Input. And name the search button Playground Order Search. Inside the loop block, use Fill Text Field. Select the input box you just captured and set the input content to current item. Then use Click Element to click the search button. After running it, the web page will run the searches one after another. In addition, for each item in list also supports checking the output loop index, which is used to get the position index of the current loop item in the list, namely the loop item index below renamed to current item index. To make the effect more straightforward, we'll turn off the fill and click commands and use print searching for current item. The current item index item in the list. In this loop, the first item we pull out is t-shirt, and it gets assigned to current item. Since it's the first item in the list and lists are 0 indexed, current item index gets set to 0. After printing, the loop moves on to the next iteration. In the second iteration, current item is assigned dress and current item index is set to 1. The loop moves to the next iteration once printing's done. In the third iteration, current item gets hat, and current item index becomes 2. The program stops after this print. The final result will be 3 printed messages. T-shirt is the 0th item in the list, dress is the first item, and hat is the second item. Finally, let's cover how to loop through a group of elements. In the last lesson, we went over what an element is and the specific way to capture a single element. But in real-world work, you'll more often run into scenarios where you need to process multiple elements in bulk. For example, clicking all the Mark as Delivered buttons on a page or pulling the status of all orders. In cases like this, do we have to capture these elements one by one? Is there a way to grab multiple elements at once? The answer is yes. Next, let's first get familiar with the core concept: similar elements. Similar elements are a set of elements with max similarity. Just like this column of order statuses, whether it's their position on the page or display style, they have obvious similarities. Capturing them is super simple. First, capture the first element. Click Capture Similar Element. Then capture a second element that's similar but not identical. At this point, Automa will automatically analyze the shared attributes or characteristics of the two elements so it can find all other elements that match this pattern. That's how we can pull the status of all orders. So if you only want to retrieve elements with the status finished, how do you go about it? First, figure out their max similarity. Their displayed text is finished. So as long as you select an element with the status finished, when capturing the second element, you'll get this specific group of elements. Isn't that easy? Finally, here's a question to think about. Does each item in this row of orders count as similar elements? Feel free to try it out yourself and share your answer in the comments. In Automa, to loop through a set of similar elements, you need to use loop through similar elements. Next, we'll use a simple example to explore this in detail. The requirement is to process the delivery for all orders on the current page and mark them as delivered. The steps to handle a single order are: first, click this order's Mark as Delivered button, then click Confirm in the pop-up confirmation dialog. To handle multiple orders, you just loop the single order shipment operation multiple times. In this process, what keeps changing are the delivery buttons for different orders, while what stays the same is the click the delivery button and confirm the action sequence. So the loop item is this column of Mark as Delivered buttons, and the loop body is the 2 click actions. All right, everything's clear. Let's start building right away. Step 1. Capture this group of similar elements. First, capture one delivery button. Then click Capture Similar Element to capture the second delivery button. Capture all 10 elements correctly. Rename the group to Playground Order Delivery Similar Element Group and hit Done. Step 2. Loop through the delivery Similar Element Group. Drag Loop Through Similar Elements onto the canvas. The web page object is blank right now because we haven't grabbed the web page object yet. Just hit Done for now. Use Get Specified Web Page. Name it Playground_webpage. And drag it to the first row. Then reopen Loop Through Similar Elements. This time, the web page object gets recognized automatically. Set the target to the delivery Similar Element group you just captured, and name the delivery element obtained in each loop Current Delivery Element. Step 3. Set up the actions that need to loop. Inside the loop, you need 2 click commands. First, click the delivery button for the current iteration. Then click the Confirm button. Go capture the Confirm button and name it Playground Order Delivery Confirm. Duplicate click element and adjust the target to the Confirm button you just captured. All right, run through the whole flow to see how it works. The page on the left is clicking the delivery buttons one by one. Once the run is done, it successfully processes deliveries for all orders on the current page. That's the specific way to use loop through similar elements. It's mainly used to loop through a group of elements with max similarity. Of course, loop logic also supports nesting. You can put one loop inside another to build multi-level loop structures. What's more, nesting isn't just limited to condition inside, condition, or loop inside. Loop conditions and loops can also be nested inside each other too. Flexible nesting combinations let you handle all kinds of complex business scenarios and write smarter automated flows. Up to this point, we've not only built the loop logic for automatic page turning, but also the loop logic for delivering orders on the current page. Now we'll combine these two loop logics to hit a more complete goal. Once we finish up the orders on the current page, it'll automatically turn to the next page to keep processing, going until all orders across every page are wrapped up. We copy over the two flows we built earlier. In the original loop logic for page turning, each iteration only ran the click next page action. Now we need to tweak it to first process deliveries for all orders on the current page, then run the click next page, meaning drag the flow that loops to process orders on the current page to before the click action. After deleting the extra command and hitting run, you'll see the page on the left is looping through all orders on the current page, and the corresponding command on the right is highlighted, stuck in a loop running command 7 to 8. Once all orders on the current page are done, the flow will automatically click the next page button, jump to the second page to keep going, and so on until all 5 pages of orders are wrapped up. This nested structure lets the inner loop focus on processing single-page orders, while the outer loop handles automatic page turning. Together, they get the batch processing of all orders done. Once a loop starts, is there really no way to end it? Is there any way to control the loop? Of course. We can use the next loop command. This lets the loop skip the current loop item and jump straight to the next one in certain cases. We can also use the exit loop command to end the loop early when specific situations come up. Next, we'll go over their usage and applicable scenarios one by one. Building on the list loop flow we set up earlier, this logic runs sequential searches for these 3 items in the order page's search box. Suppose we just got a last-minute notice the dress items are out of stock. We want the loop to skip dress and jump straight to the next item. Basically, we need to add a check for the current loop item. If it's dress, skip it. If not, run through the normal process. Let's put this together. Inside the loop, add an if condition to check if the current loop item equals dress. When the condition is met, use next loop to skip the current loop item. Hit run, and you'll see that after finishing the search for t-shirt, it goes straight to hat. And there's no mention of dress in the printed logs either. What exactly went down in this loop? Let's break it step by step. First iteration, current item gets assigned t-shirt. The condition isn't met, so it keeps running commands 7 to 9, then moves on to the next iteration. Second iteration, current item gets assigned dress. The condition is met, so it goes into the conditional block, hits next loop, and jumps straight to the next iteration. Third iteration, current item gets assigned hat. The condition isn't met, so it keeps running commands 7 to 9, and the loop wraps up. When you want to make the loop skip the current round and move on to the next one when something specific happens, you need to use next loop. Let's take an even more extreme case. Now I want the loop to stop right away when it hits dress, and there's no need to handle hat at all. That's when exit loop comes in. Disable next loop. Drag exit loop over. Hit run, and it ends right after the t-shirt is done. First iteration, current item gets assigned t-shirt. The condition isn't met, so it keeps going to run commands 8 to 10, then moves on to the next iteration. Second iteration, current item gets assigned dress. The condition is met, so it goes into the conditional block, hits exit loop, and ends the loop immediately. That's the full loop process. When you want to make the loop end as soon as a specific situation comes up, you need to use exit loop. Actually, a common way to use loop control is to stick a conditional structure inside the loop. If the condition's met, you skip it or exit the loop. But keep in mind, If you set exit loop inside a nested loop structure, it'll only exit the current loop, not all loops. Besides the command types we covered earlier, the loops set also includes other loop types. Folks who are interested can try them out one by one. Finally, let's wrap this up. A loop is made up of a loop item and a loop body. You can use next loop and exit loop to control when the loop ends. A loop can contain another loop, and conditionals and loops can also be nested inside each other. The core goal of loops is to let the robot keep running through huge amounts of repetitive work nonstop. Loops are pretty abstract logic. When you're actually building one, it's best to start with the innermost loop body, then work your way out to identify the outer loops that nest it one by one. Make sure you clarify two things as you go: what actions the loop needs to run, and what the loop's target is. That way, you won't get stuck in logical confusion. At this point, we've wrapped up the core content on conditionals and loops for this lesson. These two features are basically the core backbone of automation operations. Conditionals give robots decision-making ability, letting them make different choices based on different scenarios. Loops grant robots high-efficiency operational, allowing them to handle massive repetitive work with ease. They can also be flexibly nested and combined, which covers most everyday automation needs. I encourage everyone to get hands-on. Go over today's content on conditionals, loops, and nested logic, and try combining them in practice. If you run into problems during setup or want to explore more ways to use the commands, feel free to chime in and discuss in the comments section. All right, that's a wrap for this lesson. See you next time.